Hello everyone, also from my side. I'm very thrilled to have the honor to open the Empower conference with my keynote. Thanks David for the introduction. I think you already mentioned quite many important things about security, vulnerabilities, and what can happen if you still run old applications and if you don't change with the world that is changing around you. My name is Florian. I'm part of Bug Bounty Switzerland. I'm one of the founders of Bug Bounty Switzerland, serving as CTO there. So I have a technical security background. I think this fits quite nicely with the people that are sitting here. If I should go too deep into technical details, please let me know. Just wave with your hand or just shout at me, then I will try to change it a little bit back. I like vulnerabilities, I like security, I like talking about what can go wrong, and that's what we are going to do in the upcoming few minutes that we are spending together here. But maybe to start, it is important to give you a short introduction of what we do, and that you know where this information, all those data that we are going through, the vulnerabilities, where they are coming from. Basically, what we try to do is bringing hackers with companies together with the goal to uncover vulnerabilities and find them. When the hackers are successful finding them, they get rewarded with what we call a bounty. That's why those programs we do are called bug bounty programs, and it is also part of the name of our company. You can also think about our company as a marketplace in the end. The central part of it is kind of a bug bounty platform. It's the market where all the companies can publish their systems they would like to have included in the tests. We have the hackers that can look for new targets to engage, and we are also part of it in a small area where we help companies tackle those vulnerabilities, try to understand them, and also make sure that the collaboration between all those three parties is running smoothly and that everything works as it should work. This leaves us in a very interesting position in the end, because we see quite many systems we test at scale with the help of our hackers. We have a very unique viewpoint to the inner workings of security or insecurity or vulnerability of Switzerland mainly today, but also abroad. And this is what this talk should be about. I've just listed the numbers from the past year. We served 50 customers. For those 50 customers, we tested roughly 5,000 systems, maybe. That's always a bit hard to get right, this number. Most often we test entire attack surfaces, because the interesting things, you will find them where you normally don't look. That's one of the truth. So if you always test where you think you should test, you will miss the most interesting stuff that is happening. And on those 5,000 systems during the past year, we got reports about 2,000 vulnerabilities. And this is a very interesting data set to do something with it. What I tried to do, or what we can try to do together now in the next minutes, is taking the most interesting stuff, the juicy stuff out of all those 2,000 vulnerability reports, combine them together, build them together, and try to create a really straight line to catastrophe, to just create something theoretical that you can do to ensure that you have problems as fast as possible. We call that the express lane to catastrophe, and that's what we're going to do now. By the way, the picture here, this is what you get when you ask an AI what this express lane or this fast lane looks like. I find it very interesting and probably not that wrong. Okay, then to start with, the first example I brought here is not that technical, so we start slowly. It's more about the methodology, about some numbers. But what we see, if you want to stay vulnerable, if you want to keep your vulnerabilities, the easiest way to do that is just don't look for them. It's very obvious, and as we can see here, it is also quite easy to get that right. The two graphs that I have included here is some numbers from our platform, and to find those 2,000 vulnerabilities on the 5,000 systems, there was more than 6,500 hacker engagement pairings necessary to uncover them. So if we just make sure that nobody looks at our systems, we can be pretty sure that we can keep the vulnerabilities for ourselves. When we don't look for our vulnerabilities ourselves, we should also make sure that nobody else is doing it. What I show you here is some statistics as we see them every day in our programs. On the left side, it's a traditional bug bounty setup. The max bounty that was defined here was 3,000 Swiss francs for a critical vulnerability. There wasn't that much happening. We thought about spicing it up a little bit. Together with the customer, we increased the max bounty to 30K, and almost immediately we got a vulnerability about the remote code execution on a productive e-banking system. It was with a bank, together with a bank. So to ensure that nobody else is looking for vulnerabilities, think about the incentives, don't create them, and make sure that they're not there, and then you can stay as insecure as you'd like to be. This gives us the first two steps on our express line. Don't look for vulns and prevent others from doing so. The second example, it starts right where the first one ended. We made very sure that we follow rule number 1. There was a test running together with a customer, and some of the systems have been excluded from the test. We don't know exactly why they have been excluded, but they haven't been in there. But as we see, hackers can be very thorough. They look everywhere, and we got this report in the end about some stuff that the hacker found, but he found it during passive recon, and he just thought, yeah, I know it is not part of the test, but maybe I can let you know. So if rule number 1, not looking for vulnerabilities and trying to ensure that nobody else is doing it, fails, you need something else. What we have here is something called exposed Spring Boot actuators. I don't know if you're familiar with it. It's more from the Java world. The Spring Boot framework is a very well-known, famous framework for doing quite a lot of things. And there is this functionality in it called actuators that, if you have a look in the official docs, it allows a developer to easily monitor and manage an application. And the second part, and that is written there, all those endpoints are considered sensitive and secured by default. Jumping back briefly, we got the report with those endpoints exposed to the internet. And it's about some ICS system, some storage. I don't know exactly what it did, but it was connected to some part logistics. The hacker only did what they always do. They try to prove that the vulnerability is there, and then they stop. Again, if we look into the official docs, the definition of an actuator is very spot on, I think. It says actuators can generate a large amount of motion from a small change. And the large amount of motion here is with those endpoints exposed. You leak a lot of information. One of the endpoints here is dumping the heap, so you can download the heap of the system that is running there, containing all the secrets, all the environment variables, everything. And the second thing that happens normally when you have those exposed, it leads to remote code execution, not directly, but almost in all the cases we see them, the hacker can execute code on the system in the end. Back to our fast lane to disaster, we have the two next steps, the two next points on it. The first one is just expose what you can expose. Even if it's only for developers, just put it out there. It makes your life easier. If you do that, you will have a lot of fun. And then the second part, security is not always the best friend of usability or the developers. So if you have secure defaults, just disable them and your life gets a lot easier. Okay, let's move on to another example, the third example. When you look at it, the hackers, they are always very friendly. They address the security team. And here we have a report from one of the hackers that found kind of an interesting software installation that allows to organize once more logistics. It's about cooking stations. And yeah, in the end, it was protected using a login page. It is the login page that is visible here. But the hacker just saw that there is a list of default users on this login page. And when selecting one of those, you could just log in without any password. So if you just kept it empty, everything worked, and you have been in that system. Maybe you think this is very uncommon, those problems. I can assure you they exist more than you think. It is very, very easy to get it wrong. It's maybe not that easy to find it, but it happens all over the time. There isn't that much to say in addition here, but maybe a little bit of context. The test where this happened, it was for a hospital. The system was productive. And what we got as information, we're not completely sure, but what we got is all those functionality. It was used by different devices, paths that they handed over, and it just needed to be very easy to use that. So it was probably an intentional change that they just removed the password and everyone could use it. And yes, you could read, modify orders, meals. You could change how those meals are combined together and to whom it was distributed. So simple mistake, the impact I'm not so sure if you think about patients with special needs regarding their meals, and you could just modify it from the internet, could probably lead to some bigger problems. Okay, then back to our express lane. What we tried to do here is to think about what was the problem behind here. I think the first obvious one that we see quite often is it was about usability in the end. The system needed to be usable from all over the place, and it should be easy, fast for the people to do that. So if you want to make sure that you're insecure, just focus on usability and make it happen without any security at all, then it will work. The second part that we also see quite often is it is kind of a non-traditional IT system. It is not integrated into the normal office network. It is not part of the thing that is managed quite closely, and that makes it much harder to make sure that all those policies are applied and that you follow all the things that theoretically should be in place. Because I'm pretty sure with the hospital where that happened, they have everything in place. They have policies in place regarding password complexity. They require a multi-factor authentication, everything. But if you have this kind of system living its own life somewhere out of this context, it just is not helpful at all to have those things if it's not applied there. Okay, let's step up the game a little bit and get a bit more technical. The next example, the next vulnerability is about cryptography. I just leave the upper part of the report here, and we can see that the hacker identified something called AES CBC bit flipping, the vulnerability. We can also see that it's about the 0 day. It's something that is not known today. And what the hacker also states here already, it is quite complex. So let's try to go through it without all the complexity. It started with the obvious step that is quite at the beginning of quite many vulnerability reports. There is a web application firewall in front of it, so we're safe. We don't need to care about safe cryptography. It prevents everything bad from happening. Interestingly here, the bypass was not that hard to find. It's not rocket science at all. It was enough to just switch all the slashes with backslashes, and then we have another reference to rule number 1. Don't have the people look at it. Here with the simple change, a lot more functionality was exposed in the end, and the hacker got access to the admin panel to the system. Another reference to rule number 1, the algorithm, the cryptography, it was proprietary. So nobody knows exactly what is happening there, so we should be pretty safe. What we also saw, that hackers can be very thorough. Here in this case, the hacker could have a look at the algorithm because the source code leaked using another vulnerability. So he combined that together. He had a look at it, what they implemented. And the last one, we use encryption, military-grade encryption. Good luck getting past. But as we see, crypto can be very hard to do that right. So maybe it's not a good idea to focus on that alone. This is AES in CBC mode. I'll skip quite a bit of the complex things, but I think the most important part here is that without tamper protection applied, it was written here, one of the problems is it's this crypto mode without tamper protection. If you don't have that, you can mess with some of the encrypted blocks, and if certain conditions are right, you can change one block by making the first one unusable. And sometimes this is enough to do something very bad with it. If you're interested in the full report, we have that ready with all the confidential information stripped, so just reach out to me. I'm happy to send it to you. It goes on a little bit. The hacker did exactly that. He identified the important part in the ciphertext in the end, where the interesting thing is happening. He identified where this is. It was at the fixed place. And then he started playing with it, tried to modify this block by making the previous one unusable. Fortunately for the hacker here, it worked. The previous block or the previous part wasn't necessary at all. And so he could do some changes in the crypto or in the ciphertext that is encrypted to do something interesting with it. Maybe to give you the full context, the algorithm and the cryptography, it was used in kind of a single sign-on scenario. You could log in to this admin panel. It was an admin panel for a SaaS application, so quite many customers on it. And they implemented it in a way that it generates kind of a deep link with all the authentication and authorization information in it. It sent this deep link to the target application, and if the encryption is fine, then you are authorized with everything that is part of this link. The hacker was very nice. He provided us with a 15-line Python script in the end. It started by getting the ciphertext. It's an encrypted state. It was a .NET application for those who know it. He then started identifying the block that is interesting with some part of well-known clear text. He modified it, flipped the bits, everything, and in the end, he created an URL that we could use just to click on it, and we have been admin to the backend system and on the system with full power. Yeah, sometimes that's all it takes for the hacker. We don't know exactly how much time he invested to find it, but it was quite significant. Back to our highway to disaster or to hell. I don't know to where it should go. With one simple text, yes, do crypto, but if you want to make it insecure, do it yourself. It is very hard to implement it in a good way. The next example, so far we skipped one of the big areas of today. Maybe you can already see it from the title of this example. It is about going to the cloud. Yes, I agree with you, David. The cloud is normally much more secure if you rely on it, but on the journey to the cloud, a lot can go wrong. And this is what we saw here. We had this program running, and the report in the end, it states that some cloud-based system, it is even running on the Switzerland North Cloud of Azure. You can see that here. And the first step is one of the cloud-based systems fetches some data from a second cloud-based system. It is, as we can see from the endpoint, it is about configuration data. And what we also can see, the endpoint is public, so everybody can do that. and it is not only config data that is coming back, it also contains some kind of key material that you can use. This key material can then used on another cloud-based endpoint, exchange it for some access token, then use another endpoint with this access token and fetch some more data. In the end, the hacker identified an endpoint where he could authenticate with all those access tokens, and what he got back was credentials to quite many other SaaS systems that the customer was using. So it was a nice chain, or combining all those steps together to get more privileges with every step. In the end, the systems where he found credentials contained quite a bit of data. I have included the last part of the report. The hacker just casually asked us if he should send us some juicy data from the customers to prove that he really can access it. What we normally do is we ask them to send one sample so that it is very easy to prove that the vulnerability really works, but not dumping everything. Maybe a bit more context for this vulnerability is it was with quite a big bank here in Switzerland. Part of the test setup we had was that we excluded the e-banking for the only reason that they tried to avoid having problems with legally protected data leaked. Because with vulnerabilities on e-banking systems, it can be a bit dicey what happens if you really have something there. But in the end, we had this data nonetheless, even without the e-banking. So it can be very widespread around, and we think it is quite a good example of what can happen if you just build something in the cloud. Maybe you did it this way in the past, where you have been protected by big walls around it, but when it's shifted to the cloud and exposed and everything is available publicly, you should probably try to do it a bit different. Yes, with this last step, we have our express lane now completed with the examples that we combined for today. The last steps, it is more about, again, how you approach doing things. If you just keep doing it in the same way as you did it in the past, and you just think, let's move it to the cloud, and we're fine, it will probably not work. So to recap very briefly, if you want to be insecure, stay insecure, and if you want a very high chance to be the next victim of a data leak, here are 8 easy steps to follow. Don't look for vulnerabilities, prevent others from doing so, expose what you can expose, it will make your life way easier. Disable all those nasty security defaults. Just do it and you will feel a lot better already. Usability through no security at all. Make sure that people can work. Time is money in the end. Make sure to have that right. Skip all those IT systems that are related to a bit more the physical world, shifting toward OT, everything. Make sure they have their own life, they live their own life, separated, undisturbed from the reality of the cyberspace. Yes, do crypto, but do it yourself. And in the end, just keep doing what you all the ways did before, but do it publicly available in the cloud. It's very beautiful, isn't it? I like it. Yeah, with this, I'm already quite at the end of this short keynote. maybe for you, it's very important to keep in mind in your daily work. If you see some patterns, maybe just a single step, it could be worth thinking that you are somewhere on the road to catastrophe. Just think about it and try to think what can happen and do it better. Thank you very much.
You're doing bug bounties. My question that I raised after the first few slides, you have pretty much sensitive information in your systems.
Mm-hmm.
How often do you bug bounty your system, your own system?
Our own system. Of course, we eat our own dog food. So our platform, just short teaser, it is running on the Microsoft Cloud, Switzerland North, Switzerland West. We have been part of the Microsoft for Startups program, so we got very good support from the guys around here to make it secure. We have a lot of sensitive information from regulated industries. We have the vulnerabilities for quite many Swiss banks, for the government, so it is kind of an interesting target or an interesting system to protect. And one of our main pillars is, of course, doing a bug bounty. So we have all the hackers, everything looking at our system all the time. That is part of it.
What's like the timeline of such a project? So, and also what I'm interested in is how is like the connection to these hackers, or how you like recruit them, and how is to work with these, and you also have like bad experience with such person, or?
The first question about the timeline, the shortest programs we do is around 2 to 3 weeks. That's the max you can do. What can happen is that we stop them after the first day. So if we run out of money, or if the system is just riddled with vulnerabilities, it can happen. So it can go very fast, but we cannot rely on it. So we need a bit of time to make it happen if it's not happening by itself. The second part about recruiting the hackers, it is everything about access to interesting profiles. What we see is the hackers are where the interesting programs are. So you need interesting targets, you need good enough incentives, and then they will come. What we try to do is we do quite a lot and very active outreach when we identify people that we know that are especially capable of doing bad stuff on the technologies that we have in scope. We try to recruit them. We reach out to them, say them, hey, we have something, we have good bounties, why don't you have a look? And the third part of the question about bad experiences, we don't have any that are worth to mention. What happens when you do these things at scale and you involve a lot of people, it creates a bit of work to just make sure that you get the thing that you like to get out of it. But really bad things where hackers didn't comply or did some really bad stuff, that normally doesn't happen. The hackers are on the weak end of the of this entire system, and if something goes wrong, they lose the credibility, so they won't be included anymore, and their income is gone, basically. So that's a very strong incentive to keep them on the good side.
What did you say was the most prevalent and at the same time easiest to fix vulnerability that you typically see?
Yeah, what we see a lot, because when you have a look at the digital footprint of organizations, it is web-based today, so that means we see a lot of web-based vulnerabilities. Many of them are not that interesting. It's just another boring XSS. You need to get rid of it. So I think that's the majority of it. But what we see also quite a lot is the one about unintentional exposure. So you have some features exposed, and normally that is very easy to fix. Just remove it from the internet, and then it is safe. with the actuators. What I didn't mention, for example, this was part of a system that the customer just bought from a vendor, so he couldn't even do that on his own. So if you don't know what you expose, how should you protect yourself? You need to look for those things, otherwise you won't find them. So it makes it a bit hard to get it right, but the fix would be very easy in the end.